Okay, Robert, here it is. I think I realized the mistake I was making, if you call it a mistake. All right, here's what happened. We had v that equaled 9, and then, of course, pi was 22 over 7. So when we fill this in, we end up getting the 27 on the top, and this denominator ended up being 88 over 7. All right, and we know it's the cube root of all this. All right, so that we established in class along further ahead here, we could split this up now, and this would end up being the cube root of 27 over this cube root of 88 over 7. Okay, so far so good. So now, we could also split this up. So I'd end up being, let me make sure I'm clear, the cube root of 27, and that's going to be over the cube root of 88 over the cube root of 7. All right, so far to continue. I don't know if I made sense. I'm looking at a text and answering it at the same time, so that didn't make sense. All right, so at this point, now we can do the keep, change, flip, maybe, possibly. And I believe that's going to end up being times, and then up top it will be the cube root of 7, and then over the cube root of 88. Okay, so far so good. And let's see, now what shall we do? Let's go with, let's see, keep, change, flip. I did that right. So now the top is going to be the cube of, we know what this is. It's like 27 times 7. So when I do that, it's going to be, this will end up being, the cube root. So the 3 comes out, and then I've got the cube root of 7. All right, and in the denominator here, I need another cube or something, it looks like here. So, when I'm figuring this out, let's see, I could take the cube root of 88, and we decided that was, what comes out, 2, and then cube root of 11. And that's what that ended up being, 2 of them. Okay, yeah, and I'm going to put this, that simplified to here, I'm going to put it underneath this 2 cube root of 11. Okay? Okay, so let's see, this is where I'm at. I had 3 taken out. All right, that sounds good. And now from here, it looks like I have to rationalize this denominator, and that's what we didn't do in class. So if I'm going to rationalize this denominator, then that means I'm going to have to multiply top and bottom by, let's see, this is just a single root of 11. So I want to make this, the 3 over 2 can stay, and then I'm going to multiply the top, which is cube root of 7. And what am I doing here? I don't want to do that. I'm repeating myself basically. So let's say we do it this way, and I'm going to multiply top and bottom by just the root, though, not the just the root, not this 2. So that means I'm going to multiply top and bottom by. I have 111 here. I need 2 more, so that would be like 11 to the second power, and top and bottom, cube root of 11 to the second power. Do it equally. Now I can go ahead and say, what's the bottom going to be? Well, the cube root of 11 times the cube root of 11 squared is the cube root of 11 to the third power, which is easier to figure out. So these two end up equaling 11 times 2. So that gives you your 22 on the bottom. The top, the numerator here, is going to be, let's see, I've got 11 squared, which is 121. And I'm going to multiply that to the 7. And this will be in the radical. So when I do that, let me slide down here to say I've got 121 times 7. That's 7, 4, carry the 1. There's that 847 we were looking for. And that's going to be like this, which is 847. And then I had a 3 with it, this 3 here. And so this ends up being the answer. And I got to remember to put a 3 here for the cube root. Seems odd that I can't break that up, but I can't because it's 11 times 11 times 7. And I need a cube root, so nothing can come out of that. And I hope that's okay. I hope you're getting what I'm saying. And okay, that's it. I will talk to you later. Let's see here. I'm gonna